Thank you all for coming. This is Elixir Security, business and technical perspective. My name is Michael Lubas. My promise for this talk is that you'll get a new point of view on a topic you're either very familiar with, which is Elixir, or you're learning about it for the first time. There's numerous benefits that the language brings to your organization, and more people should be aware of them. For my background, I'm the founder of Praxeal.io, which is a cybersecurity company that's focused on Elixir. My entire professional career was in security before I learned Elixir, so to my security friends, I'm the Elixir guy, and to my Elixir friends, I'm the security guy. And what I found working in security was that major vendors weren't even aware of Elixir's existence and the impact that it's going to have on the future. Praxeal.io, it's an Elixir security platform for stopping attacks and ensuring the software is secure. Also available through the company is developer security training, which is focused on Elixir, as well as penetration testing services, which is specialized in the language. To begin today, I'd like to tell you a true story about a bank that has a security problem. So imagine a banking portal where you log in through your laptop or your smartphone, and you want to log in, check your balance, and maybe do a transaction. One day, though, when you log into your bank account, you enter your username and password, and there's likely a 2FA token, you are placed into the wrong bank account, somebody else's. And you can do transactions, you could do withdrawals, and it's a security disaster. It's kind of the worst case scenario for a financial institution. And this really happened to a bank, where the problem was when two people logged into the application at the same time in very close proximity, Noah on the left would be logged into Mike's account. This security problem has several names. The most technically correct are data race or a thread safety issue. You'll also hear people call this a race condition, which it is. However, race condition refers to a larger set of problems. So it's technically data race. If someone says race condition here, that is still correct. This story is from a cybersecurity textbook, the Web Application Hacker's Handbook, published in 2007. The authors found a real bank that had this problem and were advising them on how to fix it. You might be thinking 2007 was a long time ago. Surely software development and security has advanced to the point where this isn't a problem anymore. 14 years later, GitHub, which is a very important organization, everyone here knows them, it's where most of the source code in the world is stored, had a security problem. The title of the postmortem blog post, How We Found and Fixed a Rare Race Condition in Our Session Handling. If you were logged out of GitHub on March 8th, 2021, it's because people were being logged into the wrong GitHub account. GitHub is based on Ruby on Rails, which is a modern language. They have very smart people at GitHub. It's just a very difficult problem to deal with in the majority of web programming languages. And I begin the talk today because Elixir completely solves this problem of data races and thread safety issues, just due to the inherent design of the language. And this is a security milestone, which the language gets very little credit for. It completely eliminates this class of vulnerabilities, and yet most security people aren't even aware of Elixir today. So during this talk, I'd like to expand on these benefits. So from a business perspective, where does Elixir and Phoenix sit in an organization's network? In the bank, for example. It's going to be on the public-facing web servers. So I'm on my phone. I want to check my bank balance. My cell phone is the client. It's communicating with the bank's web server. That's where the Elixir or a Java or a Ruby app would be hosted. And you can imagine you're on the go. You want to check your bank account from home or when you're traveling. That web server has to communicate with the public internet. And there's good people that want to check their balance, and then there's bad guys that want to steal your money and cause damages. So Elixir and Phoenix in the network stack are sitting at this point where they have to accept malicious requests and be able to handle them in a secure way. And the language does a fantastic job, but I want to explain what happens if this is not the case, if the software you have running on this web server is not secure. Equifax is a credit ratings agency here in the United States. They had a major data breach a few years back, and the financial settlement cost alone was $425 million. It was very notable too. Several senior executives left. It was so notable, the United States Senate actually commissioned a report titled "How Equifax Neglected Cybersecurity and Suffered a Devastating Data Breach." And if you read this report, it's full of references to Apache struts, that there was a public exploit for Apache struts. Equifax was not patching Apache struts. And this isn't a Senate report. Like, the United States Senate was interested in the patching of Apache struts. What is that? It is to Java what Phoenix is to Elixir, where if you're making a web application, a banking portal in Java, you're going to be using struts as the tool to make that website. Very similar with Elixir, it's the language, and then Phoenix is the tool you're using to make a web application. In 2019, RiskSense did a study on vulnerabilities in web frameworks. So you're making a website with a web framework. How vulnerable is that code? And first place, so the kind of worst one, was WordPress. Third place was struts. And somewhat surprisingly, I don't think many people even saw this report, the most secure framework was Phoenix. It was last place in terms of vulnerabilities. And the obvious rebuttal is Phoenix is new, Elixir is new. Of course it would be lower. And I think that that does a disservice to the incredible design that went into this technology. It was influenced by the security issues that Rails saw. The designers thought about this. And when you look at the code and when you use this technology, you get the sense that they really thought it through and designed it well. So I think the rebuttal of, oh, they're new, it really doesn't get at the heart of the achievement that Elixir has in this space. For some business context, there's a man named Peter Drucker who coined the term profit center in 1945. So within businesses, sales and marketing are sometimes classified as the profit center, and then product, design, engineering, QA, and security are seen as cost centers. And some businesses really take this to heart and operate it. In 2002, he published a new book that said, I was completely wrong about this. I should not have used this term to describe businesses. He said that the only profit center in a business is a customer whose check hasn't bounced. You know, your salespeople are very important in generating revenue, but it's ultimately the customer deciding to give you their money that generates revenue. And that decision also hinges on, is the product engineered well? Does it work? Is it secure? Am I receiving good customer support? So sharper businesses understand this. They understand you have to invest in this. And I really like the analogy of picking up pennies in front of a steamroller, where you can save a few dollars today by neglecting security and neglecting uptime and going with the lowest bidder. But especially in technology, you have this looming steamroller of major downtime or your product not working well or a security breach looming behind you. The other important part of this is that in the long term, Elixir tends to save businesses a lot of money. Pinterest saved over $2 million per year in server costs alone. And after the migration, they found that the performance and reliability of their system went up despite running on drastically less hardware. This is shocking if you're a business person. And if you know Elixir and Erlang, this is expected. It's the expected result. The technology is designed for systems like this. Bleacher Report had the same story. They had a monolith running Ruby on Rails with 150 servers. Following the move to Elixir, it went down to about 5. And the order of magnitude of saving is just insane. This does beg the question, if Elixir is so much better, why are other languages more popular? There's not an easy answer to this. I just want to contribute one perspective in the overall area of this. Python was released in 1991. Today, it's one of the biggest programming languages in the world. 13 years after Python was released, Paul Graham, who's a very successful startup investor, founder of Y Combinator, published an article, The Python Paradox, where he said that at the time, in 2004, Python was not popular. If you wanted to get a job in 2004, you learned Java. And it was a fight to get a company to use Python in production. Now, he's interested in startups, and he notices that companies that use Python are able to hire much higher skilled developers compared to other companies that are big and have brand recognition. And he says that the people who are learning Python in 2004 are going to be higher skilled programmers because they're learning it out of passion for their craft. And in turn, you want to hire those people. They're not learning the language to get a job, but they're telling you that they're more likely to be a good hire because they really care about the work that they're doing. This pattern is likely familiar to the Elixir developers watching this talk. The language was released in 2012, and we're only 11 years in, so not even the 13 that we saw in the previous slide. And despite the relative new language compared to Python, there's hundreds of companies using Elixir in production very successfully, and they're getting to take advantage of these benefits. And many of them see it as a competitive advantage over the rest of the marketplace. So Elixir is a very good language to be writing your software in from a security perspective. It's not well known, but it's because it's the up and coming, next generation of software. For the more technical portion of this talk, I'd like to discuss the secure coding and deployment hardening guidelines. It's the guide for Elixir code that the Erlang Ecosystem Foundation, the security working group, published. I'm part of that. Most people are probably aware of this already. If you're not, I highly recommend checking it out. But I'm very excited to make this announcement today. We have a new document that actually that's releasing right now, and it is the Web Application Security Best Practices for Beam Languages. So this is live now. You can take a picture of this slide too. It's on GitHub, it's published, and we really want feedback from the community on what do they think of this document. It's intended to help you write secure web applications with Elixir and Phoenix. And all of the recommendations are in one document now, instead of scattered over the internet. For the earlier example in this talk, the data race with the bank account, the reason this isn't possible in Elixir is due to the Erlang runtime, where processes are isolated threads, they don't share memory, they communicate through message passing. So the root cause of the data race issue is when you have two operating system processes manipulating the same variable in memory in a very short period of time. And if you know how the Erlang runtime works, you just understand that that would not happen. So I highly recommend this talk, The Soul of Erlang and Elixir. It goes into a lot of detail on how the Erlang runtime system works. And if you want to understand why that is from a technical level, this is the talk to watch. For the current upcoming languages, Rust and Go are definitely new. And Rust especially gets this reputation of being the secure language. And a big part of that is for code that's dealing with memory corruption problems. So think of a web browser or the Linux kernel that's written in C. A big thing with Rust is safety in that area. The thing with web applications is they're written in memory-safe languages today. And this safety reputation that Rust gets, it kind of extends over into the web applications written in Rust. We really haven't seen a strong framework emerge. There are frameworks in Rust, but not to the popularity of Phoenix yet, for example. Go has also seen incredible adoption. It's seen as a concurrency-oriented language. It still does have data races. It also has a data race detector, so they did think through that well. But you really haven't seen a web development framework emerge for either of these languages in the same way you've seen with Ruby on Rails, for example. And I mentioned Rails because I think it was a huge security accomplishment. Giving developers the ability to write code that's secure by default with cross-site scripting or SQL injection. This did more for AppSec than probably the entire security industry. This was a huge accomplishment. And I think Rails deserves a lot of credit when it comes to writing secure web applications. With Elixir and Phoenix, I see it as continuing that achievement, where you have this mature web development tool set with no data races. The uptime and reliability is amazing. The standard library, for example, Ecto makes it so difficult to introduce a SQL injection vulnerability. You're not worried if you're going to call the wrong function and your whole code base is going to get owned. You also don't see the proliferation of dependencies with the NPM ecosystem. It seems like a small number of very reputable people are writing the core Elixir code that most of us are using. The only article I've been able to find on the security benefits of Elixir was written in 2021 by Nathan Long, titled Elixir is Safe. And he discusses the data race issue. He compares it to memory safety, how memory-safe languages eliminated buffer overflows, and then Elixir will do that for concurrency programming. Then something interesting happened. There was a paper published with the lead. Despite Elixir being perceived as a safe language, our empirical study shows programs written in Elixir to contain vulnerabilities. This isn't surprising because all software can contain vulnerabilities, and this wasn't Nathan's point. This is from Vision for a Secure Elixir Ecosystem, published in the ACM in 2022. I don't think this paper paints an accurate picture of Elixir's security. I published an article in response to it. Elixir is still safe. It's the cheetah picture on the blog. If somebody mentions this paper, I would not recommend it in a business context. I think it is not an accurate representation of the security benefits of Elixir. So if you are using Elixir in production, the very important point I want to make is you should use Sobelow, which is the stack analysis tool for Elixir code. It is by far the best open source tool. It's very well known in the community. The creator, Griffin, also gave a talk at ElixirConf in 2017, plugging the security holes in your Phoenix application. If you're at all interested in security, you should watch this talk. One thing you'll find with Sobelow is it's very much created for people that understand security, that you know what all of these terms mean. One thing that I've personally wanted was sort of a guide to triaging and fixing Sobelow findings. So this is part of the Prax-CLIO product, but I've also released it as open source. So you can go on the website and see for each Sobelow finding, what is it, what is this vulnerability, how would a bad guy use it, and how do I fix it in my code. So Sobelow is a fantastic accomplishment, but let's say you want to see an Elixir application that is vulnerable. Well, what does vulnerable code look like? How can I try out Sobelow on a target where I know I'm going to find something good? Potion Shop is an intentionally vulnerable Phoenix application. It's vulnerable to remote code execution, which was the Equifax bug, SQL injection, and a number of other problems. Jonathan and I created it with support from the EEF, so a big thank you for them. And it covers basically the standard security problems you will see. People who are learning Sobelow have said Potion Shop was very helpful in getting them up to speed with the tool. So going back to that Equifax example with Apache struts and Java, remote code execution is possible in Elixir. It doesn't solve every security problem. So I want to use this talk as the opportunity to tell you, if you see this code pattern in your base Erlang binary to term, you have user input, and then there's a safe atom, you might be vulnerable to remote code execution. And the reason is you can dynamically create a function at runtime in Elixir. So a bad guy could send a payload the function would be created, and then they would have the equivalent of production SSH access to your server. You're owned at that point. If you want to learn about how that works, I published remote code execution and serialization on the Praxial blog. It's the picture with the power lines at dusk. There's also Exploit Guard. So this is an open source tool I released. It's part of Praxial.io as well. Essentially, it's able to detect at runtime if a new function is being created through binary to term. This should never happen in your application at all. It's a very good signal that something bad has happened, and it uses the built-in tracing with Erlang. So it's incredible how good the tools are, and I wish more security people really knew about Elixir and Erlang. This is the slide with too much text. I recommend taking out your phone and taking a picture if you want to dig into this later. The full list is the EEF guidelines, which we covered at the start. Bram is the head of the security working group. He has a blog. I recommend subscribing to it. Griffin also publishes. He's the Sobelow creator. I'm publishing on the Praxial.io blog about security. There's the link to Potion Shop, Sobelow, and then also Holden, who's the current maintainer of Sobelow. He released a series of live books for training people in OWASP Top 10, common web security issues, and I highly recommend checking that out. What I find so exciting about Elixir today is that you get the sense the language was designed for the next 10 and 20 years of software. And if you're watching this talk, whatever your role is, if your organization is considering using Elixir, you have a role in that. You're looking ahead, and you have the ability to build the future. Thank you.